What I wanted to talk to you guys about today is not get too deep into what Epson's doing just from a spec or hardware perspective, but more talk about what we've learned over the last 5 years within the enterprise market and how we're trying to develop products that are really ready for scalable implementation. So what you'll see from Epson is really that across the board, we've been in this space for a while. I think people always still come up to me with the question, and Jay knows he's been working with us for a while. They say, Epson, why are you guys in this space? Aren't you a printer company? What drove this need to get into smart glasses? And so it's really comes down to one thing and one thing only, and that is we have a lot of background in projection. So Epson is the world leader in projector technology. I always grimace if I look up and find that it's not an Epson projector, because then I get in trouble during my presentation, but roughly 50% worldwide market share. And with that expertise in projection, we've miniaturized it to a very small level to enable compact, energy-efficient smart glasses. But the thing to talk about today is what makes us kind of unique and different versus a lot of the other players in the market is we are hyper-focused on driving products that are scalable. And what we mean by that is mass manufacturable and at attractive price points that can really be pushed out across an organization. And so over the last 5 or 6 years, we've had a lot of opportunities to learn from our mistakes, to put products out that haven't been perfect for a market, and figure out how we can take them to the next level where they'll be more ready to be implemented in a wide fashion. So just to show you a little bit about what drove some of these advances here. Gen 1 2011, really just a developer kit that Apex at the time, or now Upscale, they were some of the first to really pioneer and take it and add capability to it. They and other solution providers started taking it out to the field. And the biggest questions we got were, at the end of the day, no matter how much technology you put in a piece of glasses, if it's not light enough to wear and doesn't have a form factor that fits for an everyday field service repairman, person on a job site, it's just not going to work. We don't care how cool it has to be light enough, small enough to really work. There was also, of course, plenty of other learnings we had as we tried to go into places like oil and gas or areas that had specific certifications. ANSI certification for safety glass, intrinsic safety for oil and gas, IP ratings for depending on what environment you're in. We've learned a lot over the years, and as you can see from the evolution of this product category, we have several different products that are intended to meet several different product areas. In our parent company, Seiko Epson's perfect world, they would have built just one product and we could ship it to everyone and it would work and everyone would be happy. But really, we found that's not the case. The one on the left, I get embarrassed because they somehow ended up using my photo, but it's the BT-300, one of our most recent products. It's been very successful, but it's really an end-user consumer device that just targets the drone market. What I want to talk about more is these two on the right. The BT-350, which addresses the commercial market, that's the product we announced today, along with our two products that are very specific to the high-end industrial market, critical job environments where you need things like OSHA standards and really a compatibility with hard hat, safety glass, etc. So as you can see with Epson, one big thing is the feedback has really driven our product roadmap. Every year we're going to come out with additional product based on direct end customer feedback, because as we started to take products into the pilot mode, we went to them over and over and said, what is stopping us from taking 10, 20, 100 units and turning that into 500, 1,000, 10,000? And really it came down to very specific requirements. So I want to talk just a little bit about the BT-350 and then really just open it up for questions that you guys might have for Epson. Unfortunately, as Jay can probably attest to as well, and a lot of you know, we can't tell all the specifics of the customers or the exact feedback, but just the general ideas of things that we're learning and why we think this product in particular, the BT-350, is ready for scalable implementations. The biggest difference is it's really built for multi-user environments. And what we mean by that is with this product line, we found that everybody has a different head size. It's something that's so simple, but so important when you're trying to roll out product across thousands of people. And so one thing that's very unique about this product, and if you haven't had a chance to try it on, I recommend giving it a go, is a new hinge design that's designed for about 90+% of the population, from people with very narrow heads all the way up to very large heads, along with everywhere in between. It really accommodates a very wide range. And the idea is that at the end of the day, again, if you take it to the job site and it doesn't fit one person, that can kill the whole project. There were so many times we'd be out there and someone would have a really, really wide frame Warby Parker glasses or some cool glasses that it just didn't fit over. So this type of product, the idea was, let's get down to what makes the most sense and just at least keeps us in the game. Other things is around really the display. People told us over and over, Epson, you guys are good at making projectors, but the display has to be as crisp as possible. When we're out there, everyone has different eyesight. 60% of people wear prescription glasses, contacts, something where if that display is not easy enough to read for anyone, again, it can be a project killer. So Epson has manufactured its own OLED technology. Very unique for us is we actually make the panels ourselves. It comes from our expertise in projectors, and they're custom built for this product, both the BT-300 and the BT-350. What it enables, for those who are familiar with OLED technology, whether it's on a TV or on other smart glasses, OLED allows full transparency. Many of you have probably seen from products Epson and other companies have made. When you don't have OLED, you get this gray box effect. This light's passing through a projector, and you can always tell there's this virtual screen hovering in front of you. When you're working in a critical job zone or on a high-value piece of machinery, it has to feel natural. It cannot block the actual piece of machinery. OLED, the beautiful kind of revelation with that is that you can finally have that full transparency to only add the relevant content, to only add the instructions in the right place, and hopefully enable that person to do the job more effectively and more efficiently. And then other little things include really trying to focus on the multi-user environment. So all of us, Epson, every company, we're all guilty of trying to build a really cool proof of concept, show it to a few executives and say, look, this is the future, we can do it. But then when rubber hits the road and we try to roll out across 100 or 200 people, or 10,000, we find, wait, are we going to update these units one by one? Is there a way to charge all of these units at one time? There's the little things that can, again, be project killers. So with this product, really tried to focus on a few of these other areas, including making sure it fits every single person that tries it on, ensuring that the durability is higher so it can withstand the fact that all of us have different size heads, and then again, that we have device management options. So I just want to skip ahead to one other slide that shows kind of what I'm talking about from a device management perspective, and then just open it up to any questions you guys have about some of the specific learnings or just general questions about rolling out within the enterprise. But let me pop this over here. I realized too late that we only had about 10 or 15 minutes, so my apologies for sliding through all these. But here's the one I want to show you is just Epson's really focused again on trying to be realistic. What do companies need to push this out into real implementable scenarios? And things like this, the ability to charge multiple units at once and to control them from a PC so that if you were rolling out thousands, instead of updating each one by one, you have device management software from a host PC, push that update to 20 units at once, and ensure that whoever the IT manager is on site does not hate you, that you're every time you put a patch or an update to your software out. So it's simple things. I think really the focus of our experience in the presentation today is that no matter how exciting we want to be with rolling out really cool demos, really cool experiences, at the end of the day, the things that limited us, Epson, with really getting from that proof of concept stage to implementation was not always thinking through the bare bones. Will it fit everyone? Will people be able to update them? And at the end of the day, will it really make the person's job more effective? So with that, I just want to open it up for any questions you guys might have, again, in general about either Epson, our hardware, or some of the projects we've done today that we've seen both high success and learned from.
Great, thanks, Mike.
Yes. That's a great question. So the question that I heard was that we talk a lot and we tout our ability to have fully transparent glasses using OLED display panels, but at the end of the day, the glasses are thick on both sides. And this is, I think, a common problem for a lot of the manufacturers when you're putting a lot of technology up here. And she asked, in blocking peripheral vision or any of the vision, is that potentially, obstructive to someone getting the job done? And I think at the end of the day, we're still learning. Really, what we wanted to focus on is what is right in front of the employee. As long as they have situational awareness that's not going to lead to any danger, So if we are blocking too much where it puts them at risk, or they're in an environment that could be potentially dangerous, and now they're losing a lot of peripheral vision, that's a big deal. But typically, we're so focused on people working on a piece of machinery or a task right in front of them. And the beauty of the human eye, we've done a lot of studies at a university, Waseda University in Japan, on eye fatigue and how our eyes operate around these type of devices, is that, and you've probably seen this if you wore monocular devices, your eye can almost look through pieces because the way that our eye looks, like if you're using a monocular display right here, you see it, but if you're not focused on it, you almost are looking through it at the regular world. So as long as you're not blocking too much, I think it's usually still going to be okay, but it's a very good question. We have to be very cognizant of that. And one thing Epson did with one of the other products we have downstairs is a flip-up design. You might have seen it in one of the slides, but it essentially, either if you're wearing it on a helmet or if you're wearing it on your head, it just flips out of the way. So the worker can use the glasses when they're working on something and then pull it out of the way when they want to focus or if they're driving a forklift or whatever else they might be doing. Intrinsically safe option. Whew. So that's a hard one. The quick answer is no. The longer answer is, of course, they are working on it. It was a big thing that Jay and his team brought up very early on. There's huge potential if we can tackle that requirement for the oil and gas and other industries. But just to put it in perspective, my understanding and our engineers' understanding is just for us, the magnitude of cost that it would lead to is 5 to 10x for the products we work on. So if we're already selling our products anywhere from $800 to $3,000, multiply that by 5 or 10 to really get to intrinsic safety. And for us, we didn't think that right away there's going to be huge uptake at $10,000, $20,000 price points for glasses. So we're working on it, but I have no guarantee as to when that'll happen. Pricing, that's a nice lead-in. One thing, again, that Epson is really focused on is trying to deliver at attractive price points. We have a lot of trade-offs we deal with each and every day. Do we want to put a full depth camera array or sensing array like some other products? Do we want to expand our field of view? Do we want to do X, Y, Z? At the end of the day, our engineers are always balancing price versus performance and weight. So we can certainly do a lot of these things, and I've seen it in our labs in Japan, but at the end of the day, our price points are $800 for the BT-300, $1,399 for the BT-350, and $3,000 for those two upper-end industrial products. Anything, though, that's in that enterprise or commercial space is also subject to volume pricing discounts, so there is flexibility there. But we do really try to keep the price points at places that are advantageous for implementing. Then we have a question about OLED. So this is one, and I would really encourage, if you haven't seen it, take a look, because I can't tell you how good the OLED display is until you try it. We don't have the biggest field of view. We're the first to admit that. It's only 23 degrees. But the display is, I think, unlike any other one you'll see here or anywhere. We custom develop these. It has the highest brightness, at least according to our engineers, so don't hold me to that, but by far the highest because they're custom making it for glasses. We use silicon-based OLED. Epson, we actually manufacture our own quartz silicon. We're very vertically integrated, so it comes from the ground up, and we own patents in not only the design of OLED panels, but the manufacturing process itself. The cool thing about that is a lot of products actually use OLED panels that are more for viewfinders or VR. So they're not really intended for see-through glasses, and they use an optic system to kind of drive that display to your eye, but it sacrifices brightness a lot. So I think if you take a look at a lot of the glasses, you might see wider field of view here or something else there, but brightness we're really proud of that we can get a really, really high level of brightness. Resolution of the BT-350. Both of our products that are on silicon OLED are 1280 x 720, so 720p. Are working to, of course, continue getting it up to full HD. But again, I would caution that this isn't just me saying it to defend the product, but I would challenge people to look at some companies that show full HD versus this and see which one you think looks better, because we could do full HD, but essentially it's just a difference in how you're how do I say it without getting in trouble, and how you're measuring it. You can use certain display panels that'll say you're at full HD, but by the time it comes to your eye, it's nowhere near that because you're bouncing light back and forth a lot of times and experiencing light leakage. So for ours, even though it's 720p, again, I feel pretty confident when you sit it side by side against a lot of the other displays that are out there.
All right.
Thank you.
Thanks, Mike.
That's good.